Coroutine context and dispatchers. Where do coroutines run? How do you control which thread executes your code? Today we explore coroutine context and dispatchers, the mechanisms that configure and schedule coroutines. Every coroutine has a context. Coroutine context is a set of elements that configure the coroutine. It carries information about how the coroutine should behave. Think of context as coroutine metadata. It answers questions like, what thread should this run on? What happens when it fails? What is its name? Context is immutable. You do not modify a context. You create new context by combining elements. The context travels with the coroutine. When you launch a child coroutine, it inherits context from its parent. Context contains multiple elements, each with a purpose. Dispatcher determines which thread or threads run the coroutine. Job tracks the coroutine's lifecycle and enables cancellation. Coroutine name gives the coroutine a name for debugging. Coroutine exception handlers uncaught exceptions. Each element has a key. You access elements by key, context bracket, job close bracket. Elements combine with plus. Dispatchers.io plus coroutine name of worker creates a context with both. A dispatcher controls where coroutines execute. Dispatchers.main runs coroutines on the main thread. Use this for UI updates in Android. Only one thread, so work must be quick. Dispatchers.io is optimized for I/O operations. Network calls, file reads, database queries. Network calls, file reads, database queries uses a shared pool of threads that can grow. Dispatchers.fault is for CPU-intensive work. Parsing, sorting, complex calculations. Uses a pool size to CPU cores. Each dispatcher is designed for specific work. Choose the right one for your task. Specify a dispatcher when launching a coroutine. Launch dispatchers.io runs the block on an IO thread. Async dispatchers.fault runs computation on the default dispatcher. If you do not specify, the coroutine inherits the dispatcher from its scope. Run blocking uses the current thread as its dispatcher. Launch inside run blocking inherits this. Most coroutine builders accept a context parameter. The dispatcher is part of that context. Sometimes you need to change dispatchers mid-coroutine. With context switches the context for a block of code. With context dispatchers.io brace block close brace. The block runs on IO, then execution returns to the previous dispatcher. Use this pattern. Start on main for UI, switch to IO for network, switch back to main to update UI. With context is a suspend function. It suspends in the current context, resumes in the new context. This is cleaner than launching separate coroutines. Your code stays sequential, but parts run on different dispatchers. Child coroutines inherit context from their parent. When you call launch inside a coroutine, the new coroutine gets the parent's context. Same dispatcher, same job tree. You can override specific elements. Launch dispatchers.io inside the main coroutine runs the child on IO. But other context elements, still inheritance, follows addition rules. Child context equals parent context plus any elements you specify. Specified elements override inherited ones. This makes code cleaner. Set the context once at the top level. Children inherit without repetition. Job is a context element that represents the coroutine's lifecycle. Every coroutine has a job. The job tracks whether the coroutine is active, completed, or cancelled. Jobs form a hierarchy. A parent job has child jobs. When you cancel the parent, all children cancel. You can access the job from context, coroutine context bracket. Job enables structured concurrency. Parent-child relationships are tracked through jobs in the context. Access current context with coroutine context inside the suspend function. Val current dispatcher equals coroutine context bracket continuation interceptor close bracket. Build context by adding elements. Val my context equals dispatchers.io plus coroutine name of worker. Context combine context 1 plus context 2. If both have the same element type, the right side wins. Empty coroutine context is the identity. Adding it changes nothing. Keep context building simple. Usually you just specify a dispatcher and maybe a name. Let us summarize. Coroutine context configures how a coroutine runs. Dispatchers determine which threads execute the coroutine. Main for UI, IO for input-output, default for CPU work. With context switches dispatchers within a coroutine. Child coroutines inherit context from parents. Job is the context element that enables structured concurrency. Choose your dispatcher wisely. The right dispatcher makes your code efficient.